Welcome to BYJU'S Exam Prep, the comprehensive learning preparation app for your competitive examinations. Dear friends, I also welcome for this particular Nielit 2023 series. Okay, this series is exclusively running only on our channel. Okay, and in today's session, we'll take up one of the important topic from algorithms, that is divide and conquer. Okay, as I mentioned earlier, we try to understand concepts through questions. Okay, so we try to cover the algorithms topic needed for Nielit examination, the basic rules, okay, which are needed for this particular Nielit examination through questions. Okay, so that is the main purpose of that this particular session. Okay, before starting this particular session, this is about me. Myself, Sridhar Dhulipala. I am having 20 plus years of teaching experience. You can say 22 plus, okay, because I started in year 2000 my teaching career, right? And my qualifications are given here: MTech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. And my areas of expertise are also mentioned here. You can join my Telegram group to get regular updates about my classes on YouTube, app, etc. Okay. Also, those who want my guidance, mentorship, can join my Telegram group to get the regular updates. You can also join my Facebook as well as Instagram pages to get updates. Right? So, without wasting much of your time, let us straight away start with the problems. Okay? See, mainly when you consider this, divide and conquer, first of all, we are interested in special type of recurrence relations called divide and conquer recurrence relation. But before that, we should know what is a recurrence relation. Recurrence relation means expressing a problem in terms of itself. Of course, there are many methods to solve this recurrence relation. One of the very basic standard method which you people follow is iteration method. For divide and conquer recurrence relation, we'll discuss immediately after this. We have special method called master theorem. But for some problems, no other method works. We have to go for this iterative method. Of course, after iteration method, we have to verify using the substitution method, my dear friends. But generally, for competitive examination purpose, we believe the answers obtained by iteration method or recursion tree method, and we take up those results because they at least give you the upper bound. That is the idea, right? So let us solve this particular problem. If you already know the answer, you are free to give the answers, my dear friends, right? So what I'm going to do is I'm going to use this iteration method. See, it is popularly known as substitution method, but generally substitution method is the verification method. We guess a particular solution and we prove that. Iterative method, there are two variations. One is called forward iteration, the other one is backward iteration. 99% we use backward iteration. Backward means starting from the recurrence relation, we try to find the answer, result for the time complexity. So let us see this, my dear friends. Tn value is given, which is Tn is equal to Tn minus 1 plus 1 by n. So here, if you observe, this is Tn minus 1. What is the value of Tn minus 1, sir? So I'll just keep this in the brackets and 1 by n, I write it as it is. If Tn is equal to something, see, in place of n, now we are having n minus 1. So if it is Tn, it is Tn minus 1 plus 1 by n. So in place of n, if you put n minus 1, what happens? So if you put n minus 1, it becomes n minus 1 minus 1. That is Tn minus 2. And what about this n? 1 by n, because n value is n minus 1, 1 by n changes to 1 by n minus 1. So that is the value. So that is Tn minus 2 plus 1 by n minus 1 plus 1 by n. Now again, what is Tn minus 2? See, this iteration method, we try to reduce till you make some particular observation. See, if you are able to make the observation here itself, you can directly write the final answer. Otherwise, you can do two, three more steps. Okay, reduction. We just need to reduce it to some standard form. So if you observe, it is Tn is equal to This is Tn minus 2 plus 1 by n minus 1 plus 1 by n. What is Tn minus 2? In place of n, I am substituting n minus 2. So what happens? It would be n minus 2 minus 1, that is Tn minus 3. And in the place of n, we are having n minus 2. So you get 1 by n. Now n is n minus 2. So it is 1 by n minus 2. See, now we should understand the pattern. And we should also know till where you have to continue. Till it becomes 1. See, we are writing like, Tn minus 1, Tn minus 2. Like that, you should get Tn minus k is equal to T1. That means n minus k should be equal to 1. That means k should be equal to n minus 1. So till Tn minus n minus 1, you have to continue this story. So what we do? If you observe this, okay, let me write this form. Tn minus 3, 1 by n minus 2, 1 by n minus 1 plus 1 by n. Now if you observe it, if it is Tn minus 3, if it is n minus 3, it is n minus 2. So whatever is here, this fellow will be 1 less than that. So if you make the general form, this is called observation, my dear friends. What happens? You have to continue till Tn minus n minus 1. So if it is n minus 1, this fellow would be 1 less than that. So it should be n minus n minus 2. N minus n minus 2. Of course, the last terms would be the same fellows. That is 1 by n minus 2. Very good, Shyam. 1 by n minus 1 and 1 by n. And if you simplify this, this is obviously T1. This is 1 by, see, actually if it is n minus 3, it is n minus 2. 1 more than this. So if it is 1, it is 1 by 2 and so on. 1 by n minus 2, 1 by n minus 1 plus 1 by n. Super. What is T1? This is nothing but 1. 1 plus 1 by 2 plus and so on. 1 by n minus 1 plus 1 by n, which is nothing but your harmonic series. And the harmonic series, sum of first n terms of the harmonic series is given by log n approximately. Base of logarithm does not matter, therefore it is theta log n. So the correct answer for this problem is option A. Very good, Shyam Babu. Super. Perfect. Right? That is the main idea, my dear friends, which we need to understand. And for divide and conquer recurrence relation, we should know. For divide and conquer recurrence relation, we should know what? What is that we need to know? We need to know the master theorem. Okay? So just go through this particular master theorem, my dear friends. Okay. Nice. So this is your master theorem. See, the main idea I'll tell you how to remember. It's actually called the extended version of the master theorem. How you can apply this particular master theorem, let me tell you. Here mainly if you observe this A, B and the power of n and this P are important. So we need to know note what is A, what is B, what is the power of n, that is K, and what is P, you have to identify. So we always compare A with B power K, my dear friends. We always compare A with B power K. So this A with B power K, when you compare, A may be greater than B power K. That is the case 1. In that case, the answer is simply theta n power log A to the base B. Okay. The second one, when A may be equal to B power K, this is the second case. Then depending on the value of P, that is whether P is less than, not less than, P is greater than minus 1, yeah, P equal to minus 1, or P is less than minus 1, we have the 3 different cases, my dear friends. And the third case, when A is less than B power K, then P greater than or equal to 0, yeah, P less than 0, we are having the required result. Of course, this is very rare situation, my dear friends. Even this is a very rare situation. Most of the time, you will get 1, 2, 3 and these 4 situations mainly. The questions which they ask, See, master theorem, how can you apply master theorem for previous problem, my dear friend? How can you apply master theorem for previous problem? It is not possible, right? Even there is one more version of that, that is called subtract and conquer theorem. Maybe you can have some upper bound for that. Upper bound you can get, but it will not match with your answer. Okay, so it will not match with your answer. So as I mentioned, depending on the situation, we can write the answer. If you already know, wonderful. If you do not know, follow me. So I'll be taking this particular, oh, someone already given the answer, wonderful. So here the value of A is 8, the value of B is 2. See, actually this particular extended version works when the function, that is a into Tn by b plus Fn, that Fn part is of that particular form, n power k into log power Pn. Most of the cases will get that, so I am just using that particular standard form, my dear friends. Am I clear? K value is 2 here and P is equal to 0. So first let us check what is A b power k comparison. This is 8 and this is 2 square. See, 8 is larger than 2 square. That is case 1. So obviously you entered case 1. So directly the answer is theta n power log A to the base B. This is the answer. That is nothing but theta n power log 8 to the base 2. So what is the answer for this, sir? 8 is nothing but 2 cube. So it is log 2 cube to the base 2. That is nothing but theta n cube. Log 2 to the base 2 is 1. So it is n cube, my dear friends, which is nothing but option B. Wonderful. Within no time you answered that. Super. Sorry. The next question. See, Sham Babu, rocking star today. Huh? He's not giving me time to answer. A is 2, B is 2, K is 1 and P value is not there, so it is 0. Compare A with B power K, that is 2 is compared with 2 power 1. Both are equal, so that is case 2. So once it is case 2, compare the value of P. P is equal to 0. Log power 0. See, P greater than minus 1. That is P greater than minus 1. It is n power log A to the base B multiplied with log power P plus 1. So because P is 0, log power P plus 1 means what, sir? 0 plus 1 will be log n you are going to do. So you are going to multiply that n power log A to the base B. Yeah, this function. Because here n power log A to the base B as well as this n power k, this, that is n, both are equal in this case. So you can use either of them. So directly case 2, in this P is equal to 0 means it is greater than minus 1. That is in case 2, case 1. So the time complexity is simply theta n, this n you can directly write into log power P 0 plus 1 n, which is nothing but theta n log n. That is C. मणिशंकर तिवारी, सुपर बाबू, यू आर रॉकिंग. अगला समस्या आपके स्क्रीन पर. Shyam, you know the questions which I am giving or what? Directly giving answer without any trouble. Super. A4, B2, K3, P0. Standard form. A compared with B power K. 4 compared with 2 cube. Here 4 is less than, A is less than B power K, that is case 3. In case 3, again we have to see the value of P, which is equal to 0. See, it is case 1, P greater than or equal to 0. Then directly the right side function. Okay, directly the right side function will be the answer here. So what is the answer, sir? Tn will be theta, same n power K, that is n cube, that is this particular function. Okay, log power Pn. That is P is 0 here, so log n cube only. Yeah, you can use that directly. See, there are two ways of verifying it. I am just using the extended version of master theorem. One more version is n power log A to the base B is compared with Fn. So whenever this is asymptotically smaller than this and Fn satisfy the regularity condition, then we can use the third condition. Very good morning. It's good morning, huh? Nishu Babu. It's good evening. Fine, no problem. After a long time, I'm seeing you. Okay, good. Good to see you back. Right? Wonderful. The next one, I think we answered now. So it is n cube, which is D answer. Next one. So again, super. A is 6, B is 3, K is 2, P is 1 here. So A with B power K, when you compare, 6 is compared with 3 square. 6 is smaller than 3 square. Oh. So again, same case 3 you are getting. P value is 1. Obviously, it is greater than or equal to 0, case 1. So directly, what is the answer? Right side function. That is theta n square log n is the answer. B is the answer, not D. Super. अगला समस्या आपके स्क्रीन पर. B. Sanjay Kumar says B. Today most of the people are active. I think you people are active after 10 p.m. Please let me know so that I will conduct all my classes after 10. A is equal to 5, B is equal to 5, K is 1, P is minus 1, because log n, 1 by log n means log power minus 1. So P value is minus 1. Compare A with B power K. 5 is compared with 5 power 1, both are equal, case 2. In the case 2, P value minus 1. P value minus 1 means second case. So you ignore the denominator portion, just that Fn n power log A to the base B has to be multiplied with log n. So Tn will be n power log A to the base B will be same as n, sir. N into log n. Very good, very good. P is minus 1. Yes, yes, yes. Super. Yes. Arams. Very good, Nishu. See, these questions, we can mostly answer almost all the questions very quickly. Of course, there are some other variations like, root functions or root recurrence relations. Just proper substitution can solve all the problems very quickly. See, now earlier, people used to have a lot of trouble. Now, thanks to, lockdown, after that, most of the people explored these rules like anything. So now most of the people are not having any trouble with these problems. Right. One more problem. A is 2, B is 2, K is 1, P is minus 2. Again, A with B power K, when you compare, 2 and 2 power 1 both are equal, case 2. And in this particular case, because P value is minus 2, which is less than minus 1, the third part, what is the answer, sir? What is the answer for third part? Yeah, P is equal to minus. Very good, very good. What is the answer? So in this case, that log part is completely gone and you get theta n, my dear friends. B is the answer. Theta n. B will be the answer because that log part is completely gone. There is no log power p plus 1. When p greater than minus 1, log power p plus 1. When p is equal to minus 1, log portion is completely removed, you get log n. And when p is less than minus 1, in that particular case, the log portion is completely removed. And that is answer. Hopefully you understand all these rules. Practice them well. My dear friends, I like Sham. Today you are rocking, man. Not even a single one you answered wrongly. Super. That is the spirit. Great. And all others like Manishankar Tiwari, Nishu. Nishu is a regular student. I know him long time. I think this year also you are aiming. Be connected, sir. This time we'll try to do better. Right? Next question. What is the time complexity to search element X in linked list of n sorted elements using binary search? Manishankar Tiwari, B, super, B, N, order N, Sanjay is also doing well, Sanjay, Sham, Manishankar, Nishu, well done. Order N, very good, Nishu. See here, when you are having a linked list, we are applying binary search for linked list, but that is not a good, binary search is not a good algorithm, okay, for linked list, my dear friends. But that's what I'm saying. That's what I'm saying. It is applicable, sir. Why it is not applicable? But you have extra work. So let us see how much work you do it. Let us check how much work you do it. Suppose you are having 5, 10, 12, 15, 20, 30. So the indices, okay, the numbers 1, 2, 3, 4, 5, 6. Maybe you have to maintain the indices also together with the nodes, node numbers also. Maybe you can have one extra field where it indicates or there is an algorithm called finding middle element of a linked list that you can use. Anyway, see, somehow you find the middle element and you have to traverse. See, finding number of elements, suppose you maintain, suppose there may be some header node, in that you can maintain number of nodes. That may be possible. By some means you maintain that. Okay. Then once you know the number of nodes, you have to travel till the middle node. So first time you have to travel till the middle node. Suppose you travel till the middle node. So here 6 means 1 plus 6, 7 by 2, 3. This is the middle node. Suppose you are searching for say 20. You are searching for say 20. See, obviously your 20 is greater than that. So what we need to do is from 4th index onwards, we have to search. That is 4th to 6th. What is middle of that? 4 plus 6 by 2? That is 5th. Till 5th index you have to traverse. That is 4th to 5th index you have to traverse. See, finding element is a order 1, but you have to traverse to reach that element. If you are using array directly, you can go to that element, but here you have to traverse. Okay, you have to traverse. Next time you will be traversing n by 2 square. Next time you will be traversing n by 2 cube. Next time you will be traversing like that continuously. You traverse till you are having a single element, like n by 2 power k you traverse. See here, if you are using array, reaching that element can be done in order one time. Reaching that element can be done in order one time. But here, finding the element and reaching the element are different. In array, finding and reaching the elements are same. But here, finding element can be done, that is which element can be done in order one time, but you have to reach that. So this traversal has to be done. This traversal has to be done. So here what happens if you take n by 2 common, which is 1 plus 1 by 2, 1 by 2 square and so on, 1 by 2 power k minus 1. So here I am assuming that n by 2 power k is equal to 1, my dear friends. Here I am making assumption that n by 2 power k is equal to 1. So it is n by 2. What about this sum to k terms? 1 by 1 minus 2 power k by 1 minus 1 by 2. So these two get cancelled. For cancelling, let us use red. So what happens to this? This would be n 1 minus 1 by, see 1 by 2 power k will be 1 by n. Because n by 2 power k is 1 means 1 by 2 power k is 1 by n. So when you simplify it is n minus 1 which takes theta n time. So you all answered properly, but mainly the reasoning was the problem, and that is the reasoning, sir. So the reason is this one. See, it's not like we cannot apply, sir. It's not a good data structure. Linked list is not useful to apply binary search. See, because with array, if it is a sorted array, binary search can be done. We can find the search element in log n time, in the worst case also. That is the idea. Here, worst case, it takes theta n time, my dear friends. Not good data structure. अगला समस्या आपके स्क्रीन पर. Our next session is very interesting. Greedy as well as dynamic programming. Problems on greedy as well as dynamic programming. That is, I think, on Monday. Join my Telegram group. I'll give you regular updates. This is my Telegram group, my dear friends. CS_Sridhar. Nishu says order n. Wonderful, sir. Normally, you know, binary search. Okay, if you are having a sorted array of n elements, binary search takes log n time. For n elements, it takes log n time. So for n square plus 2 power n terms, how much time it takes? Log of, sorry, n square into 2 power n, not plus, sir. N square into 2 power n. Log AB can be written as log A plus log B. Correct or not? Which is nothing but 2 log n plus n log 2. That is nothing but log n plus n. Drop lower order terms and you are going to get the answer theta n. Big O of n you can write. This type of question, see, my dear friends, I know that most of you might be prepared for GATE and all. The questions here, you can think about the question which just now we seen. That question is also a very possible question. This type of questions I found in this Nielit examination. This not exactly same. This similar type of ideas were asked in Nielit examination. So for merge sort, whether it is average case, worst case or best case, all are n log n only. For merge sort, all complexities are n log n only. Wonderful, wonderful, Manishankar Tiwari, super. Okay, so the idea is for merge sort, we have the recurrence relation always, because we divide the array into two parts, recursively divide the array into two parts, then we recursively merge them. So the merge process together with all other constant works will be theta n work. So the time complexity for merge sort will be, in all the cases, it is 2 into t n by 2 plus theta n work. And using yes, using master theorem, you can easily verify the time complexity in all the cases, because this is the recurrence relation in all the cases. So this is obviously that is a b power case same, p value is equal to 0 greater than -1, that is the first case. So what is the time complexity, sir? Tn is equal to theta n log n. Super. All the cases it is n log n. This type of questions also very common. Combinational questions. See, for gate point of view, they become very basic, but here you can expect some basic logical questions also, or such, memory based questions. It's not memory based. All the algorithms, when you see, obviously nowadays people trying to remember every result, but for every algorithm we have a procedure why that particular time complexity we can derive all those results. Right? D, because insertion sort worst case is theta n square. Merge sort in all the cases it is n log n. Quick sort worst case is n square only. Quick sort worst case is n square only. See, quick sort, the basic idea for quick sort is best and average cases are n log n. But most of the time quick sort performs average cases. And surprisingly, quick sort gives you worst case performance for already sorted arrays or reverse sorted arrays, or when the elements are equal. For these type of arrays, this fellow will give you worst case performance. Because of that, quick sort is not adaptive. Quick sort is non-adaptive sorting. Whereas insertion sort is an adaptive sorting. Because when it is already sorted, insertion sort is a better sorting algorithm. How many maximum elements comparisons are required to merge two sorted arrays with 10 and 20 elements each into a single sorted array? Maximum elements comparison. Huh? 31. See, for sorting or merging two sorted arrays of length m and n, the maximum element comparisons would be m plus n minus 1. That is 10 plus 20 minus 1. That is 29. Okay, the merged array size will be m plus n. But comparisons required maximum will be m plus n minus 1. Very good, Shyam. Super, Nishu. Okay, super. 29. Manishankar, please check Nana. And this type of questions are very common for Nielit type of examinations. So he's asking about merge sort algorithm. You know, for merge sort, the time complexity is theta n log n. So what we need to take for such problems is, whenever they give, we assume that some constant times of n log n as the complexity we can take it. So C n log n we can take it. And what he mentioned for size 32, it takes 20 seconds. Tn is equal to 20 seconds. So with this we can find the value of C, my dear friends. That is C into n log n is equal to 20. that is C into 32 into log 32. 32 is nothing but 2 power 5 is equal to 20. C into 32 into 5, log 2 is 1, which is 20. 5 fours 20. So C is equal to 4 by 32, that is 1 by 8. So you got the value of C, my dear friends. Very, very good evening, sir. Namaskaram, Chandan Kumar. A for Assam. Very good, quick, very quick to answer. Nice. So now what happened? For input of size 256, what happens? So just use C into 2, that is Tn. You need to find Tn, sir. We need to find Tn. Tn is equal to C into n log n, which is nothing but C, that is 1 by 8 into 256 into log 256 is nothing but 2 power 8. 8 cancel and you are going to get the answer 256. Hopefully everyone is doing well. अगला समस्या आपके स्क्रीन पर. You have an array of n elements. Suppose you implement quicksort by always choosing the central element of the array as the pivot. Good, good. See, one thing which I like is the standard questions. You people are rocking like anything. Okay, wonderful. So now I think those who are preparing, again, a small suggestion for you. There may be some subjects which trouble you. So you start with them and try to see if it is very difficult for you. At least you try to see that you reach a standard level to that. Am I clear? And of course, the subjects which are already doing well, nice. You can give time for them, revision time. But the subjects which you haven't explored much, try to see that you prepare well for those subjects. Am I clear? And you can connect with me, sir, always for any help regarding your preparation. Am I clear? You can join my Telegram group. I think most of you are with my Telegram group. So you can ping me personally also to discuss anything, sir. Okay, right. You have an array of n elements. Suppose you implement quicksort by always choosing central element. See, generally what happens in the quicksort, we select a pivot element. Okay, I'll just take a small example for those. All of you are comfortable with the direct answer. I'll give you the direct answer. Otherwise, I'll give you the detail about this. Quicksort, I think. See, because we cannot expect the same old student every time, because a new student coming for this particular session. So that is how the classes will continue. Am I clear? Okay, concept wise, if you want to understand, the idea is like this, sir. In quicksort, what actually happens is, suppose we are having an array of numbers. Let us say 10, 5, 25, 18, 16, 28. Suppose these numbers you are having. See, what actually happens in quicksort is, we select one element as the pivot element. Generally, the first element will be the pivot element. But here what he is saying is, he is selecting this central element as the pivot element. See, there is a difference between a central element and mid element. Central element and mid element. Now here the central element is maybe 25. Central element is 25. Maybe 6 elements are there, no? 1 plus 6 by 2 means third element. This is the central element. So instead of selecting 10 as the pivot element, he selected 25 as the pivot element. But keeping that pivot element there working is very difficult. So see, normally in quicksort, first element is selected as pivot element, key element. You can select any element, my dear friends. Okay, you can select any element as the pivot element, but here he is asking you to select the central element. See, whatever element is the pivot, now immediately swap with the first element. So what you do, you immediately swap this element with first element. So what happens? It is 5, 10, 18, 16, 28. And from here onwards, the procedure is same. See, again, this is your first element. It is pivot element. You can consider it as some key, which is 25 or pivot. Now what you do, I will start here, j will start here. As long as the value at I is less than or equal to 25, you have to move this less than or equal to 25, yes, 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 less than or equal to 25, no. I stops here. Now j, 28 is greater than or equal to 25, yes, move right, move left. 16 greater than or equal to 25, no, stop. 16 is not greater than or equal to 25, stop. Now once ij are crossed each other, the position of j is the correct position of 25. So what you are going to do is, you are going to swap the first element with the current position, that is aj is swapped with pivot, I mean a low, aj is swapped with a low. So what happens for this, with this particular operation, sir? 16 comes here, 5, 10, 18, 25, 28. This year I'm not planning to share any PDF, sir, because most of the people are not doing any practice, keeping the questions. Okay, I wish you write down. Okay, you can take screenshots, you can keep it. That is not a big deal, huh? Right? See, unnecessarily just PDF. So if you are just wanting my PDF, I don't want you to attend my classes. Okay, just for PDF sake. Okay, here concepts are discussed. We are trying to solve some problems together. That is main agenda for this, not supplying PDFs. Okay. See, from initial time I am against that, because if you see offline, no teacher will give you their PDF. In the market, the notes will be available. People go through those notes. So don't depend on the PDFs, sir. They are not going to help actually. You can get much better problems than this in many books. We have so many nowadays available, like, workbooks and all. So the agenda is not that to supply the PDF, sir. Yeah, I'm teaching. Yes, I'll teach algorithm. Again, I start with data structures, and both algorithms will be taken. I think in 1 week my sessions are going to start. I start with now mathematics as well as combinatorics also. Then all the sessions go together, one after the other. Yeah. Mostly from next week, my classes are starting. You can join. That is on app. So now this is the idea for quicksort. See, the main idea of quicksort is select a element, pivot element you call it. Generally, the first element is the pivot element, but any element can be selected as the pivot, my dear friend. Once you select it, you place that element at its correct position. So all the elements to the left of that will be smaller, and all the elements to the right of that will be larger than that. So here what happens is, when you do this, possibilities are, the worst case possibility would be, I am writing here, the worst case possibility would be, see, you may be, see here, you see left side we are having more elements, right side we are having less elements, or it may happen that pivot may come here. So the worst case situation is Tn may happen to be like this, Tn minus 1, and the partition algorithm, we call this, IJR moon, that particular algorithm is called partition algorithm, that will take theta n time. So this is the worst case situation for the quicksort, and it takes theta n square time complexity, my dear friends. And here, because you are selecting central element, but that central element is not the mid element, na? Central element is not the mid element. So you may get the worst case situation. So here you may get the worst case complexity. When you get the best case complexity for the quicksort, the best case complexity you get for the quicksort when the partition element exactly sit at the center every time. Mid element, that is called median element. We generally call it as median. See, don't confuse with median and central, sir. Central element is in array central element. It need not be the median of the array. Median of the array means in the sorted array, central element is called median. Whereas central element means in the array, the element which is sitting at that particular position. It need not be a sorted array, no? Note that difference. In merge sort, merge procedure is used. Here, that is merge sort. In merge sort, the merge procedure is used towards the end. See, actually in divide and conquer algorithm, there are 3 stages. Divide the problem into sub-problems, that is called divide stage. Okay, conquer stage, recursively solve the sub-problems, then combine the sub-problems. In merge sort, at the combined stage, the merging will happen. Whereas in quicksort, there is no combined stage. At the partition stage only, that is at the divide stage only, elements will be properly placed at that particular positions only. Therefore, only divide and conquer stage will be there. There is no combined stage for quicksort. That is the basic idea or basic difference between merge and quicksort, my dear friends. So the best case happens when the pivot element occupies always the central position. So in this particular case, the recurrence will be Tn by 2 plus theta n. And it will give you the complexity theta n log n, my dear friends. Theta n log n. And there is one more important case, that is called average case. See, the average case, see, it may not happen like best case, my dear friends, but what actually happens in average case is we get this kind of splits. You may get T alpha n split and T1 minus alpha n split plus theta n. So this particular reconciliation, see, whenever you are having this theta n function and here you are having sub-problems, some of the sub-problems add up to 1. That is alpha plus 1 minus alpha is equal to 1. In this particular case, the time complexity is theta n log n. But in the given problem, he says central element, it is not median. That is actually a trap. Of course, unfortunately, most of the people don't even understand the trap here. That is a different story. So it is just a central element of the array. It's not median. See, median of the array means in the sorted array, central element. Normal central element means in the given array, central element. See, that central element's correct position may be first position or last position, you get worst case situation. So time complexity can be theta n square, my dear friends. No, it's not like worst case. See, we don't like average case is taken over. It is the time complexity taken over all inputs. Am I clear? So that is how we need to understand like average case. Yeah. The next one. The minimum number of comparisons required to find minimum and maximum of 100 numbers. We generally call it as min-max algorithm, sir. It is the min-max algorithm. Nishu Kumar never fails for such problems. Very good. So min-max algorithm when you consider. So obviously what happens, sir? See here for min-max algorithm, the time complexity. Actually here we try to find the exact value, actually the number of comparisons. So when you take only the order of the time complexity theta n, but here you need exact time complexity by divide and conquer algorithm, it is 3 by 2n minus 2. Whereas there is something called straight min-max algorithm, that is 2 into n minus 1 or 2n minus 2. So here n is 100, so 3 by 2 into 100 minus 2. Very good, Vishal Srivastava, the answer is 148. Okay, so that is exact number of comparisons. That is exact number of comparisons when you, what do you call that, divide and conquer reconciliation, when you exactly solve it, you are going to get this particular answer, my dear friends. So, the last problem. Which of the following is the stable start? Which of the following is the stable sorting algorithm? Manishankar theory says it is insertion sort. Insertion sort. Wonderful. What are the stable sort algorithms, my dear friends? What are all the stable sort algorithm? Super. What do you mean by stable sort? What do you mean by stable sort? Stable sort means insertion sort. Huh? Very good, Manishankar. Bubble sort, merge sort, and what do you call insertion sort? They are the stable sorting algorithms. See, stable sort means relative order of equal keys is maintained. That is equal keys. The equal keys order is maintained, preserved. See, for example, if you consider 5 3 5 2, if you are doing selection sort, let us take, we are doing selection sorts. Even quick sort also you can take the same example. You can take this particular example, selection sort. In selection sort, first this is the minimum, then we try to identify what is the least element. So obviously this is the minimum element. So actually here, if you observe, this is first occurrence of 5, second occurrence of 5. Now what is happening, sir? Because this is the minimum element is swapped with the first element. So what happens? 2 comes here, 3 comes here, 5 here, 5 here. And if you observe, the equal keys 5 1, 5 2, that is not maintained. Now 5 2 comes first and 5 1 goes next. So this is what you mean by non-stable algorithm. So selection sort is a non-stable algorithm. Selection sort is a not stable algorithm. It does not happen in insertion sort. It does not happen in insertion sort. You can just check the same example, 5 3 5 2. So what happens? This element is taken and it is placed at its correct position. So 3 5 5 2. 3 5 5 2. Now what happens? This element is taken. Because if it is less than, it is moved to the left. If it is equal, we ignore. So 5 will be placed here itself. So this 5 and 5 2, their order will be maintained there only. Now comes 2. Now 2 compared here, compared with this 2 comes here. 2 3 5 5. The relative order of the equal keys is maintained. BFS, DFS are good possibility, very good possibility of asking BFS and DFS in Nielit examination. Yeah, I'll come up with graph algorithms. We'll solve some graph algorithm problems. Definitely. BFS, DFS, some good questions we'll take and we'll solve. I think next class, one second. Let me check when is my next session. I think on Monday and Wednesday I am having this session, sir. Okay, please do join the sessions. Okay, so the next session of mine is Monday and Wednesday. Okay, Monday and Wednesday I am having the next 2 sessions, sir. Okay, please join for those sessions. What is HQS unstable? Hi Monu, how are you, sir? I am fine, sir. I am very fine. Where, sir? Daily classes where? See, I am going to take up one data structures sessions, maybe around some number of sessions. So I just want to do some data structures. Okay, so you can attend those classes, Siri. I'll be planning. So now from next week onwards, mostly next week, and after that I'll be coming regularly on YouTube also. Okay. Monu, how are you, Monu? Doing well? Yes, good to see you all. Please do join the sessions regularly because these sessions for you will be very useful, Monu. Okay. Yeah, I'll be sharing that, sir. Definitely, I'll share to your groups. Okay. See, there is one special group. Same here, sir. Thank you very much. Okay. So there is a group. My group is this one, CS underscore Sridhar. This is exclusively for YouTube classes and app classes. Okay. So if you have any special topic in your mind, you can let me know in the group so that whenever time permits, I'll try to come up with those sessions also. This is my group only. This is a group created by me. Okay. So there is a channel. So I'll be sending broadcast messages through channel. This is my group CS underscore Sridhar. Okay. So please do join these sessions regularly, and please do inform your friends who are needing this information, courses and etc. on online. So definitely we are here. The entire team is here to help you. Okay. Please do attend all the sessions regularly. We are coming up with more and more such sessions, my dear friends. Time complex. I think yesterday reached last class I taken and I given good questions also. TOC not possible, sir, because see, I am not an expert in that because long back, almost 8 years back, I taught. Okay, but after that, I've been not in touch with that particular subject, sir. So now I don't want to experiment. Okay, if it is needed, definitely we'll do it sometime, but not now. Am I clear? See, definitely will be. I'll be interested in taking more and more subject, but time should permit, bandwidth should permit me. Definitely, we are having very good faculty in our team. Okay, they'll help you. Yes, good. Sir is very experienced. Okay, in some of the topic is having equal experience, more experience than me. Definitely, one of the great faculty is teaching you. So make use of the sessions, all the sessions. Okay, thank you, sir. So if you have any other doubts, you can ask me. Otherwise, I'll call it a day. If you have any other doubts, please do ask me. Good night. Yeah, definitely that time complexity based questions may not be for this immediate course, but definitely I'll be taking algorithm courses regularly throughout year, algorithms, discrete mathematics, engineering mathematics also. So I'll be taking classes. Please do join the sessions. I'll come up with more and more sessions for you. Even in app, you please join the app, sir. We want a student to come to our app. Even in app, we are having many such classes going on. Okay, we'll be informing it. Please join our group so you'll get regular updates about my classes. Thank you, sir. Thank you very much for your time. Thank you, sir. Thank you, Siri. Good night.